Okay, so I want to go over the answers to the questions on the inverse binomial problems. And these are excellence level questions. So if you're not quite understanding all the previous stuff, then you shouldn't be focusing on this video. You should be focusing on making sure you understand how to do normal distribution, binomial distribution, and Poisson distribution in the forwards way instead of the backwards way, which is what we're doing. So this is a department store sells boxes of 6 dinner plates. So I already know, I'm going to put that as a note, n equals 6. Don't want to get rid of that. And 22.7% of the boxes are returned because they contain at least one broken plate. Calculate the percentage of dinner plates that are broken. So we do not know our probability. This percentage represents the probability that a single dinner plate is broken, and then this here represents the answer of if there is a box of 6 dinner plates, find the probability that at least one is broken. So we're going to work the other way and find the original probability, and they're asking us to put it in as a percentage. Now we can only do this if we have the probability that x is equal to 0. Or if x is equal to 6, in this case it would work too, but we're not going to focus on that right now. So if x is equal to 0, then this here becomes 1. This here becomes 1, because anything to the power of 0 is 1. So this formula doesn't really matter, except for this part here, 1 minus p to the power n minus x. Now if x is equal to 0, this means n minus 0. So all I'm left with is 1 minus p. So that means, to the power n, so that means my formula will just be left as this. This part becomes 1 because I can't have both at once. This part becomes 1 because this is saying if I have 6 dinner plates, how many ways can I choose 0 dinner plates? That's what that part of the equation means, and there is only one way that you can choose 0 dinner plates. This becomes 1 because p to the power of 0 is just 1, and then x here is 0, so that goes away, so that becomes a 1. So it's just 1 times 1, 1 times bracket 1 minus p to the power n, so I'm just left with p to the power 1 minus p to the power n. So I'm not going to go over that again at any point during the video. So here, probably that x is equal to 0. I know the probability that x is greater than or equal to 1, so that's 1, 2, 3, 4, 5, 6 is 0.227. So probably that's equal to 0 is 1 minus that, because it's the only other option. 1 minus 0.227. So they've given me the probability of 1, 2, 3, 4, 5, 6, at least 1. All the numbers together, the probability would be 100%. Since I just want 0, it's 1 minus what I do know, and I get 0.773. Okay, so now I need to use my formula. So the probability that x equals 0 is 0.773. So that is what the answer to this would be. The probability of x being 0 is going to be this. So that's going to be on one side of my equation. So 0.773 equals, then on the other side of the equation I need 1 minus p to the power n. Now I know my n is 6, but I don't know my p. That's what I'm trying to work out. Now I can work out the 6th root. To get rid of this power 6, I take the 6th root of the other side. If this was a squared, I would take the square root of the other side, but because it's a 6th root, power 6, I take the 6th root. So I'm going to have 6 square root 0.773 equals 1 minus p. And then so to get p just by itself, I can move this 1 minus the other side, so it's 1 minus the 6th root of 0.773. 0.773. So in your calculator to get to the 6th root, you press shift, or not yet. You're going to press shift soon. You press 6, then you press shift, this little up power button here, but above it it has x square root. So now you're saying it's the 6th root of 0.773, and that gives me 0.042, which equals 4.2%, because remember it asked us to give a percentage. Okay, next week's question. The department store manager is not happy. He would like the proportion of returned boxes reduced to 13%. So remember, a returned box was when at least one was broken. So the probability that x is greater than or equal to 1 is going to return your box. So you know that is 0.13. So you need to work out the probability that x equals 0, because that's the only way the equation will work, and that equals 0.87. Now it's just the same steps. It's still the same question, so I still have 6 in my box. So I have 0.87 equals 1 minus p to the power of 6, because that's my equation. Now I need to take the 6th root. 6th root of 0.87 equals 1 minus p. And then to get p just by itself, because this is a negative p, if I took it to this side, if I took it from this side to this side, it would be plus p, and I could bring this whole thing over here and it would be minus this, so it would end up being p equals 1 minus all of this. Just a quick short explanation of how you rearrange, but if you're going for excellence, you should know how to rearrange equations. So p equals 1 minus the 6th root of 0.87. So put that in my calculator. 1 minus 6th root of 0.87. So that equals 0.23. So the maximum percentage of broken tin plates required to achieve this is 2.3%, because he asked for percentage. Okay, this question is saying, hey, how about instead of looking at the percentage of changing the percent of plates that are broken, maybe I can't change that. Let's change the number of plates in a box, because if there are less plates in a box, it's less likely that there's going to be a broken one in the box, and then less likely it'll be returned. So this one says using your answer in part A, so the probability that there was a broken plate. So my probability in part A was 4.2% or 0.042. So my probability of a plate being broken equals 0.042. And now I need to work out the number of plates in a box. I know that my maximum return rate is 13%. So the probability that x is greater than or equal to 1 is 0.13. So the probability that x equals 0 is 1 minus that, 0.87. See that that's 8. So I use my formula. So my probability of x is equal to 1 minus, that's what I need. So I need a maximum return rate of 13%. So I need it to be so I need x equal to 0 to be at 0.87. So that goes on here, 0.87. And then now I do know my P. I know my P is 0.042. And I don't know my N. Now this is one that's a little bit different to the last two, so I need to solve this slightly differently. I'm going to simplify, so 0.87 equals 0.958 to the power of n. Now to get rid of this n, we need to use logs. Now if you don't do calculus, you might not understand logs. It's okay, just know that if you go log 0.87, you don't have to do anything else to that side, but when there's the n up here, we're going to put a log on this side too, but the n then comes in front. So it becomes equals n log 0.958. It's just a log rule that you learn in 12 MAC. But it's the only rule we need for stats. So the n comes in front, it becomes n log 0.958. And then I'm going to rearrange that. So this is n times log. There's a little invisible times in here. So to get rid of that log 0.958, I'm going to remove it to the other side. So log 0.87 divided by log 0.958 is equal to n. And I go into my calculator. Oh, I was already there. So log 0.87 divided by or over, it doesn't matter what you use, divided by log 0.958, and I get 3.25. So n equals 3.25. Now I can't have 3.25 plates in a box. If I had 3 plates in a box, my probability would be less than 13%, which would be good. But if I had more than 3.25, it would be more than 13%. So I don't want to have more than 3.25 in my box. So the maximum number of plates I can have is 3. And then to finish it off, this question says, calculate the expected return rate for the new smaller boxes. So I'm going to do my normal way of doing binomial now. So I have n equals 3, probability of 0.042. I'm trying to calculate probably that x is greater than or equal to 1. Now, to do that, I'm going to work out the probability that x equals 0 and take it off 1. So go into my calculator, distributions, binomial, BPD, because I'm just doing one exact value, variable, x equals 0, num trials equals 3, I only have 3 in my box, probability equals 0.042, and I get 1 minus 0.88. I'm just going to round it to 2GP, and that equals 0.12, which is less than 13%, which is what I want. Okay, it took longer than I thought, but I'll do the next answers tomorrow.